Hello friends, this video on Vector Algebra part 5 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 4. Now let's understand the various types of vector. The types of vector which we are going to study is zero vector, unit vector, coinitial vector, collinear vectors, equal vectors, negative of a vector, free vectors. Let's study zero vector. A vector whose initial and terminal position coincide. They are called zero vector. They don't have any direction, right? They don't have any direction. They can be assigned any direction, right? They don't have any direction because there is no magnitude of this vector. The initial and the terminal position coincide. We'll rarely use such kind of vectors because if there is no magnitude, no direction, there is nothing, right? It is equivalent to a term zero in mathematics. Why? But still we use zero a lot. Why? Because you take any number 981, let's suppose you multiply with 0, you get 0, right? So it is still powerful. You take any number, you add with 0, you get same number. So 0 is very powerful. In spite of the fact that 0 doesn't have any magnitude, it is very powerful. Similarly here also, in this case, my zero vector doesn't have any magnitude or direction, but still it is very powerful. We'll use this in terms of multiplications, and we'll say that we'll multiply and the vector becomes 0. When you multiply some magnitude vector, one heavy vector with a zero vector. We'll talk about all those things. Unit vector. A vector whose magnitude is 1 is called unit vector. And it will have some direction. That guy is called unit vector. Coinitial vectors. Please note, it is vectors now, no vector. Why? Because when it say coinitial vectors, two or more vectors having same initial point is called coinitial vectors. For example, I have this vector, let's suppose they have 5 vectors. This is vector A, vector B, vector C, vector D and vector E. All these vectors start from this point. So they are all coinitial vectors. Please note, coinitial means same initial, right? Co is same initial. So two or more than two vectors having same initial points are called coinitial vectors. Collinear vectors. Two or more vectors are called collinear if they are parallel to same line irrespective of their magnitude or directions. For example, I have this vector, I have this vector, I have this vector. You see, all these vectors are parallel, but the magnitude is different. This guy may be 2 units, this guy may be 8 units, this guy may be 15 units, this guy is in positive direction, this guy is in positive, this guy is in negative direction. But still, they are all parallel, all are parallel. So they are called collinear vectors. Because they are all parallel vectors. Here, it can be in this direction, it can be in this direction, it doesn't matter. But it has to be parallel. It can be this big, it can be this big, doesn't matter. The direction should be same. That's all. Co is same, linear is direction. If they are having same direction, they are collinear. The next category is equal vectors. So when talking about vectors, they should know what are equal vectors. Two vectors are called equal if and only if they have same magnitude and same direction, regardless of their initial point. Doesn't matter. For example, if I have this vector, I have this vector. Both have same direction and same magnitude. For example, 8 units, and both is in northeast, right? Then they are parallel, irrespective of origin. The magnitude and direction has to be. If it is in this direction, this guy will be southwest, 8 magnitude. These are not same, but these are same. Why? Because the magnitude and direction has to be same. I'm least bothered about initial points. Not bothered about it. The only thing I'm bothered about is magnitude and direction. If a magnitude and direction is same for two vectors, then they are equal vectors. Correct? Negative of a vector. Negative of a vector is nothing but a same vector that is same magnitude but opposite direction. For example, this is my vector A. Same magnitude, opposite direction will be minus A vector. Just you rotate that particular vector by 180 degree. The new vector which you get, the dotted line, will be negative of vector. This guy is A vector, this guy is minus A. Correct? Free vectors. Vectors that doesn't change when it is displaced without changing direction or magnitude, of course. So I don't change direction, so I displace in parallel direction without changing magnitude, and then vector remains same. Such kind of vector is called free vector. And the point to note is we will study free vectors only. Correct? So you have this vector, you move it in this direction, this place, it is still parallel, right? And the magnitude is same, both are same. You move this side, it is same. You move from here to here, same. Given all are parallel. So if it's this vector, you make it like this, they are not same. But if it is parallel, sorry, this is not parallel, yeah. If they are parallel, that's all. They are parallel, you move it in any direction. From here, you move here, it's same. Doesn't matter. The origin doesn't matter. Starting point doesn't matter. What matters is what is the direction and what is the magnitude. So in this case, the magnitude is same. For example, let's suppose this is 9 units. This guy is also 9. And direction is same. For example, this makes 30 degree with the x-axis. This guy is also making 30 degree with the x-axis. So both has same magnitude and direction. So both are same actually. So the kind of vectors which are same if you move them parallelly and don't change magnitude are called free vectors, and we will deal only with those kind of vectors. Let's represent a vector. So I have to represent graphically this displacement of 40 km for 30 degree of east of north. So this guy is north, south, east and west. 30 degree east of north. So you take north as base, you take 30 degree here. So let's suppose you get this line. Correct? So this guy is 30 degree east of north. I got direction. Magnitude. So let's suppose this guy is 40 km. So this is my vector which is 40 km and 30 degree east of north. So it has a magnitude, it has a direction, and that's how I represent this. So it may be that you stand here and you say that my house is from my point 30 degree or 40 km 30 degree east of north. So in that case you can specify your house. If you don't specify direction, 30 km from this point O can be any point in this circle. You take any point in this circle, that point will be 40 km. So you take this point also, it will be 40 km from this origin. Correct? When you specify only direction, it can be any distance. It can be 10 km, 20 km, 30 km, 40 km. Thus, to specify your house from this point, neither only direction was sufficient nor only magnitude was sufficient. You needed both magnitude and direction. Correct? For example, in this case, when you say from here my house is 30 km, then your house could be any of these houses in this red lines. When you say my house is 30 degree east of north, your house can be any house in this line. There can be n number of houses. But to locate your house, you need both magnitude and direction. That's how it's all about vectors. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.